So, we can define isocost line as a set of input bundles, each of which costs the same amount. The analytic approach for finding the maximum output that can be produced for a given cost is superimpose the isocost line onto the isocont map. In figure, the tangency point L star, K star is the input combination that yields the highest possible output Q naught for an expenditure of C. Also, please notice that the problem of producing the largest output for a given expenditure is solved in essentially the same way as the problem of producing a given level of output for the lowest possible cost. The only difference is that in the latter case, we begin with a specific isocont, the one that corresponds to the level of output we are trying to produce. Then superimpose a map of isocost lines, each corresponding to a different cost level. As shown in the figure, the least cost input bundle L and K corresponds to the point of tangency between an isocost line and the specified isocont Q naught. Recall from our earlier discussion that the slope of the isocont at any point is equal to MPL divided by MPK. The negative of the ratio of the marginal product of L to the marginal product of K at that point. Recall also that the absolute value of this ratio is called the marginal rate of technical substitution. Combining this with the result that minimum cost occurs at a point of tangency with the isocost line, whose slope is equal to W divided by R. It follows that MPL star divided by MPK star is equal to W divided by R, where K star and L star again denote the minimum cost values of K and L. Cross-multiplying, we have MPL star divided by W is equal to MPK star divided by R. Equation has a straightforward economic interpretation. Note first that MPL star is simply the extra output obtained from an extra unit of L at the cost minimizing point. W is the cost, in dollars, of an extra unit of L. The ratio MPL star divided by W is thus the extra output we get from the last dollar spent on L. Similarly, MPK star divided by R is the extra output we get from the last dollar spent on K. In words, equation tells us that when costs are at a minimum, the extra output we get from the last dollar spent on an input must be the same from all inputs.